And so here's our rents that we're going to pay in Sao Paulo. And what is the same about each of these is that every time I want to calculate my next year's rent, I multiply it by the same factor, 1.04. So in this case, we're not adding the same amount to get to the next quantity, but each time I go from one value to the next, I'm going to be multiplying by a fixed number. In this case, the 1.04, where that 0.04 comes from the fact that we had 4% inflation. So if I wanted to calculate, say, what's my rent in 2030, I don't have to calculate my rent in 2021 and then 2022 and 2023. Each year that goes by, we're multiplying by another factor. So for example, we could have calculated our rent in 2024 by simply saying my rent initially was $400, and to get to my rent in 2024, I had to apply this factor once, twice, 3, 4 times. So I could have calculated this in one shot, and that would take me straight from the value here 4 years later down here. So in general, in t years from now, that means we can generalize this pattern, and that would have a formula which looks like R is equal to 400 times 1.04 to the t, right? So every year that goes by, we multiply by another factor of 1.04. So here is our model for the rent in Sao Paulo as a function of time t years from now. And this is our first exponential model. So let's look at what are some of the general properties of this model. So let's first take a look at this graphically to look at some of the properties that we see. And so first of all, this 400 that we see over here, right, that's reflected over here. So this is telling me what is my initial value? In this case, what is the rent in year 0? What is the rent in 2020? The other thing that's important to note here is that, again, we don't have a linear relationship. So what's happening is every time I say increase by 5 years, the change in x is fixed at 5, but the corresponding change in y is going up. So what we can see is that as time goes on, for a fixed change in x, we're not getting a fixed change in y. In fact, y is increasing more and more rapidly as time goes on. So with exponential growth, we see that the average rate of change is not constant. The average rate of change is increasing. Okay, and we can see this because the graph is getting steeper as we move along. So that's one big distinction to make there. We don't get linear graphs, we get graphs that bend upwards. Okay, next let's take a look at how we can interpret the different components of this formula. Okay, so let's summarize some of the main points from this section, and we'll discuss these details more in class. So exponential models, we use these when we want to model things that are growing at a constant percent. So such as if inflation is 4% per year, exponential model would be a good choice to use there. And so for example, these equations have 2 parameters in them. So one parameter is the R, and the other parameter is this P0. So as long as I know by what percent is my quantity increasing each year, and I know how much I have at year 0, then I can come up with a model and make predictions out into the future or the past. So to summarize what that P0 denotes, that is telling us what the initial value is. And so recall on the graph, that corresponded to the fact that the graph crosses the vertical axis at 400. So P0 in general is going to be our initial value. R, this is called the growth rate. If quantities are decreasing by a fixed percentage, then we might call that a decay rate. So R is telling us by what percent is this quantity increasing, and usually we represent R as a decimal. So in the example that we were looking at, just to summarize some of these quantities, we had P0 was 400, and we had R was 4%, which we can write as a decimal as 0.04. And that's what gave us this model of 400 times 1 point plus 0.04, all raised to the t. So just by knowing what was the rent in 2020 and what is the inflation rate, that was enough for me to come up with a model to project what the rent would be in any year. And oftentimes we will add that rate to the number 1 to represent the fact that we're adding it to the previous quantity, and we call that the growth factor. Or if we have decay, that would be a decay factor. So in this case, our growth factor is 1 plus R. So we get 1.04. But I could still interpret that in practical terms as it's telling me my quantity is increasing by 4% every year. And so what this model is telling us is that every year, every time I increase year by 1, to calculate the next year's rent, we multiply by this factor of 1.04. So that's how exponential models work. If you've got some questions, we'll work them out together in class. There's a quick little quiz that I'd like you to take about this material so that we have some foundation to build upon in class on Monday. Have a nice weekend, everybody.